Please stay tuned. The topic is obviously expression pushdown, or how to ship code to where data is to make distributed SQL faster. And you're going to hear from the horse's mouth. So Andrei actually worked on this stuff himself, like a good portion of this. So it's going to be a fun discussion. If you have questions, as always, just fire away on the LinkedIn comment box. You can even say hi to us. We love to talk to you folks. We'll get started in about 2 or 3 minutes. All right. So in the meanwhile, Andrei, maybe where are you based out of, just so folks get to know you a little bit?
I'm based in San Francisco Bay Area, basically headquarters of Yugabyte. And typically, I'm in the office every day, almost every day. Today I'm at home. Yeah.
Awesome. Fantastic. And what's your background? What have you done in the past? What are you working on here? Just so people get to know.
Oh, I've been working for Yugabyte for 2.5 years and have total almost a decade of making distributed databases under my belt. So it's like
awesome.
Very, very brief, but we are here to talk about technology, not about myself.
Awesome. So Andrei is too humble, but he also happens to be one of the local Postgres experts. So he knows a lot of stuff about how Postgres works under the hood. So, and you've contributed a lot to Postgres in the past as well, right?
Not exactly. I built a number of products, contributed to a number of products based on Postgres, not to Postgres itself.
Got it.
Yeah.
Awesome. Well, we're contributing heavily to Postgres here, so that's pretty awesome. Okay, great. I think we still have a couple of minutes. Once again, folks, for those of you who are joining, please stay tuned. We'll get started in a couple of minutes. The topic is expression pushdown. A lot of interesting like demos, hands-on demos. I was looking at some of the stuff that Andrei was talking about yesterday. A lot of interesting stuff about just how different it is to ship data versus ship code to where data is. So it's just going to be super interesting to talk about that. Okay, so maybe another minute and we get started. In the meanwhile, you guys can join our community Slack, yugabyte.com/Slack, or just ask away in the LinkedIn side. So post your questions wherever you have them. What are the current things you're working on, Andrei? You're working on some really cool stuff.
I'm working on basically enabling Postgres parallel query in Yugabyte. So that's some kind of distributed push down as well. Like a little bit going forward and to tell that main problem of expression pushdown in Yugabyte is that our storage node not Postgres. And parallel querying Postgres actually allows to actually provides a process to push down to, which is Postgres. And it actually implements a lot of stuff or solves problems to push down like larger query plans. What we can do in Yugabyte so far is only push down expression, basically.
Yeah.
Not plans.
Yeah, that's great. It's going to be super exciting. And okay, so we're at time. Maybe let's get started. Hi, folks. Welcome to another episode of YFTT, Yugabyte Friday Tech Talks. It's a talk for engineers by engineers. And today's topic is expression pushdowns. And the engineer I have is, Andrei, who is pretty senior and has worked on it himself. So once again, I know you just did it, but since you're officially kicking off, Andrei, maybe just a quick 30-second intro, and then let's get started.
Okay, my name is Andrei Martsinchyk. I'm working for Yugabyte for 2.5 years and have a lot of experience in building distributed databases. Most of them were built on top of Postgres, just like YugabyteDB. So let's proceed. YFTT, I was told that it is for engineer, so I allowed myself first slide to be boring text. Right? So I know engineers love boring text if it is terminal-like. So I promise you fancy diagram on next slide. But on first slide, what exactly we are talking about today. So you can see a simple SQL statement with with a simple condition here highlighted in bold. Oh, sorry. If you look at the query plan, people who are familiar with spoilers would find it familiar. Just maybe that remote word before filter and what exactly remote means in that context. So let's go to diagram.
So 1 second on the previous slide, Andrei, like just to explain what the query does, you are choosing all orders that were placed, or at least some columns from the orders that were placed on a particular date, right? That's the simple query.
Yeah, the date is 30 years ago today, and it's supposed to, return orders made on that day. Obviously, orders doesn't have an index on that field, so it has to go over all the orders and see what date on it and just return matching.
Got it.
With exactly that date.
Perfect. Okay.
So here is a diagram of a distributed database with separate query processor and storage nodes. We call it YugabyteDB, and without expression pushdown, when client sends a query, query processor has to request all the rows from storage nodes. There could be several storage nodes. I'm lazy. I just draw two, and every storage node could have a lot of rows, and every storage node returns them to query processor. Way too many rows, right? Not 2 times too many rows. A lot of, not to be overwhelmed by a number of the amount of data it could implement, like things like streaming filtering. But at the end of the day, it returns to client desired rows. So what happens if we have same system, but nodes can do filter? They basically are smart. So again, client sends query, and we send request with filtering it. We just extract filter from the query and send it down to the nodes. So the nodes return just rows that are matching. And query processor just forwards them back to client. Obvious improvement here is traffic. Traffic between nodes. And second, less obvious, is parallelization opportunities. Those requests could be sent at the same time, and all nodes can filter rows simultaneously.
I guess in the first one, without pushdown, the filter works on all the rows. The second one, every filter is on a different node working on a small set of nodes. So you get more CPU for the filter, so to speak, right?
Exactly. We have only one query processor here, and it is solely does entire work without pushdown. Sometimes parallelization is not feasible. Like if you have a sorted data set and query with order by set has to retain sorting, and your data shards are cut, like in the sequence, like this, and every shard is on each own node. So in this case, it like makes sense not to parallelize, because it doesn't, even if you parallelize, next nodes has to wait until you forward entire set of rows returned from previous. But fortunately, it is not always the case, so you can parallelize pretty often. So next is a demo. I prepared a cluster. It is 6-node cluster. It has like 16 cores, 32 gigabytes RAM nodes, and I loaded TPCH database to it. To those who are not familiar, TPCH is a benchmark for analytics type of databases, and what I like about this particular data set, it is generated. You can generate different amount of data, and it is 8 tables of different sizes, so you can choose target tables to demonstrate something and select size, so your query are not too long, not too fast. So difference, if it matters, performance differences is obvious. So 8 tables total, and
one question, Andrei, before we go on. So Jim asks, does the query processor have to wait for all of the nodes to pass back their relevant rows? Isn't it limited by the slowest node?
To complete work, yes, but it is not necessarily has to wait for last node to start. There are cases when it have to. If there is a sort after all, you need to have all rows and then you can sort them. If you do not sort, for example, if you just like in example queries, you just start sending forwarding them to client as soon as you receive. It's like completion is limited by source node, but you can start with, and there is cases when you open cursor, for example, and you don't have to wait until you have all, right? You can start scrolling over your cursor as soon as data arrive. Hope that answers the question.
Yeah. And as for the slow node aspect, it's typically only if the data is very skewed, right, in the way it's distributed across nodes. But typically, with the various forms of dynamic sharding or hash sharding or whatever it is, hopefully the data is reasonably well sharded, and so there is no heavy lagger, right? Like as most of the nodes are roughly able to process at the same time.
Yeah, and you may have like a very distributed cluster, globally distributed cluster, and node on the other side of the globe, and they just,
Yeah. Okay. Yeah. Hopefully that answers your question, Jim. Yeah. Let's keep going.
So to start, I'm going to run this is a query that appeared on the first slide. It has quite many rows, but it's pretty fast. It's like 200 millisecond ballpark, and you see it's, let me show actually the plan. So it's pretty much the same that you saw. Like it has like 1.5 million rows, and 6 nodes do the work pretty fast. Yeah, 200. With pushdown is so. What happens if I disable pushdown? Oh, maybe first, before, like we do not want like hundreds of rows of response. So I kind of prepare different queries with more strict filter. That runs only 2, and yeah, that is much easier to see. So now I'm going to disable pushdown and run same query again. You see the difference. It's like, 1.6 seconds versus 300 of milliseconds.
5 times slower almost, right? Oh, yeah.
Yeah. So, and other than that, let me show you this. That is network traffic between nodes. You see that like spike that has just happened. That's consequence of disabling expression pushdown. All 1.5 million rows had to be delivered to query processor, which is that green line. It took all the incoming traffic while other nodes were just sending. So it's like much less. And that is cloud cluster. So cloud provider is going to charge us for the traffic. So to save company money, I will enable pushdown again. Yeah. So that's how it works when it works. And, basically, question is when we want to push down question, and answer is whenever we can. And next question would be when we cannot actually push down expressions. One reason I already mentioned that is basically coming from the fact that remote nodes are not porters. And while we made remote storage nodes to execute porters code, it's too hard to fully simulate porters environment down there. So two major things, like one is catalog access. Catalog access doesn't allow to use to use functions that are user-defined. User-defined types, again, they are a problem because executor to execute, has to find details in the catalog, and catalog is not available down there, so we prevent user-defined stuff from being pushed down. And not only user-defined, Porters has a number of functions that do things to database, and basically we use volatility as an indicator that that function is safe to be pushed down. Immutable functions are safe. Immutable functions only depend on parameters. They cannot refer transactions, they cannot refer catalogs, they cannot query other tables. So they are pretty safe to be pushed down. It sounds like it's too strict, but in fact, Porters has literally thousands of built-in immutable functions. So we who actually can push down a lot of practical things. And just as an example, what we cannot, I prepared.
Before we get to that, Andrei, before we go to the mutable or other kinds of built-in functions, one question from Nandita is, can queries run in mixed mode? As in, have a set of global filters alongside pushdown filters? If yes, do global filters wait for the results to return from all nodes before operating on the data?
Yeah, you will see that in the moment. So that is basically what I'm talking about. See, that is the same filter. 30 years ago today, but literal 30 years ago today. Current date minus 30 years interval. And what we have here is current date. It is stable. Current date is guaranteed to return same date for the duration of transactions. So if you start your query a moment before midnight, you wouldn't see two different values for current date. It would be always the same. And transaction context is the second big thing that doesn't allow us to push down certain stuff. So current date, it has to be.
So I guess what you're saying is, if you push down current date, every node would evaluate its own exact time of running that query, and so it wouldn't be transactional. And doing it at the upper context gives you a stable value that you can move. Is that what you're thinking?
Yeah, every storage node would have its own view of transaction, and it is hard to synchronize them. So to make sure that current date executed in one transaction context on one node would be the same value as current date on other node, and even more hard if it is current timestamp. See, that is more obvious. They could be different.
Makes sense. Yeah, that portion cannot get pushed. Okay.
Yeah, but that particular query, you see it execute very fast. It is like 300 milliseconds.
Yeah,
and it is not because not the like 1.6 like it was without expression push down, and let us see why. So if I explain that query, I see two filters here, one regular filter and one remote. So that's basically, I hope it answers the question, that we analyze all the filters on the query and push it down those we can and execute locally in the query processor ones that we cannot push down. And important point here is the execution order. Normally, you would find you would expect that expressions in the filter are executed in the order they appear, and actually remote filters, if you think about these, are executed first. So optimizers swapped actually some conditions on the query, and that might be important if your conditions have side effect, and that is exact reason why conditions with side effect are not recommended. Basically, if you have like some storage functions that would do changes instead of current date, it wouldn't be executed, because what happens here, request comes down with remote filter, and remote filter is strict enough and applies in parallel. So query processor has like quite a few rows to deal with to apply this current date field. And since I mentioned that we do not push down something, I going to give a trick, right? To explain a trick that could be used to push down basically more. So it is based on the fact that we push down parameters. So here I prepare a statement with same query in it, but it has a parameter, right? So and parameter is pushed down, and when I execute that query with current date, you see everything is remote. So other ways to leverage that fact is to use storage procedures. Nothing comes to my head other than storage procedures that would have a parameters, but that's kind of way to let expression to push down. So another thing I would like to show today is expression push down in the case you have indexes. So I have
there was one
customer
question,
table here.
I think there's one question from Nandita, Andrei, which is what happens if there are conditions? Do you get higher execution times? Do you get an error or higher execution times? I don't know if you like.
If you have conditions that doesn't push down, yeah. I have just demonstrated that you have like
you'll have a
little higher execution time, and like to show when it is like really higher, that I remove that additional condition. You see, that is only condition that is not pushed down. You back to 1.6 seconds of execution time.
Got it.
That's the price you pay if you cannot push down.
That's the catch-all case. And okay, got it. Yeah, I think Nandita did mention you've already answered that, so maybe I read it as wrong. Yeah, got it.
Yeah. So back to the plan. So customer table, it's smaller one. I created an index for it, like which is this one. And what important here, it is by customer name, and customer name is something that is index is sorted by customer name, and it also includes customer address. So that means Andrei doesn't participate in sorting, but it is helpful when you do, sometimes you can do index only scan, which is more efficient. You need to use only index to retrieve your data and don't have to touch actually a main table. And it also helpful for expression push down. Let's look into that query. Okay, I will execute it. So you have like data, you see data, and what actually it does, it looks for customer by part of the name. So like statement, and basically customer name should start with that substring, and you, as you can guess, all customers in that generated table start from that substring. So it has to check also, first of all, it does full run over the index. All indexed rows are checked for other condition. And as I mentioned before, address exists in the index. So that is the part of address I'm looking for. It's random string, so it is unique, right? And also account balance that doesn't present in index. So let's now look into, well, so you have a bunch of filters here. So first goes index condition. That is something that our index can, know how to work with. It is like text between, prefix of like and prefix plus one at the last character. So basically that first rough filter that basically covers range we're looking for plus something, and coincidence that all our rows fall into that range. But next, you may see difference here. Remote index filter versus remote filter. So remote index filter is, basically arbitrary expression that is evaluated when we iterating over the index before we even touch the main table. And here you can see exact like statements that we provided. So if that rough condition includes something extra, that would filter that out, right? And another condition, we can push down it with index scan because it the column referenced by that condition exists there, right? And so we basically retrieve one row key out of that index and go to main table just to check that account balance is positive and retrieve all the field we ref. And again, back to that point of ordering. We try to maximize performance, so we push down our conditions as far as we can, as soon as we can, and that basically makes different ordering of conditions. Good news about this is that we do not push condition with side effect, because side effect is only possible if your function is volatile.
Basically, as much performance while maintaining the Postgres spec, right? Like exactly how Postgres does it. So,
yes, yeah. Basically, it's kind of typically stated as undocumented.
Yeah.
Exact order of evaluation, and to give freedom to implementation.
Got it. Okay, cool. I think we're at time. There's one question from Jim, which is YB enable expression pushdown flag is on by default starting in 2.17.1. Do you know if there were any enhancements made after, like in 2.19? Just curious. If you know off the top of your head, it's fine. Otherwise, we can figure it out.
We just took some time for technology to mature, like to catch cases we overlook.
Yeah,
like this. So we started with disabled it, and being cautious is kind of normal,
especially in a database. Yeah. And so, what's next? Maybe last question that I probably will ask is what's coming down the road.
Oh, we just want to push down more. So I mentioned that it's only expression today, and we would like to push down joins, for example, and it is a lot more of problems to solve, right? Unless that's parallel queries. That's something I'm currently working on, and that allows already to execute some plans, solves a lot of problems around with row gathering, work distribution. Just work distribution is kind of it's SPI. It's like we need to implement some interface functions to make it work with our tables. Basically, we need to let podders know how to divide our tables into parts for parallel processing. That's the key.
Yeah, parallel processing is super important, super cool. So awesome. Great. All right, that brings us to time. So thank you very much, Andrei. This was really, really good. Really fun to see the demos and all of the theory meets practice. It's amazing. And thanks everybody for joining us and attending. Once again, join us in a couple of weeks. Same place, same time. We'll have another YFTT episode. Until then, have a great weekend and good day and good evening to everybody.
Thank you.
Thank you. That was fantastic. Thank you.